Learn electronics by SRS Electrical Solutions. Last episode we got know about basics of electronics on electric charges, electric current, electric terms. In this episode we learn about classification of solids and energy band. We know that some solids are good conductors of electricity while others are insulators. There is also an intermediate classes of semiconductors. Difference between behavior of solids as regards to their electrical conductivity can be beautifully explained in the terms of energy band, so let us know each solid's properties and its energy bands. Conductors. Conductors are the materials or substances which allow electricity to flow through them. They conduct electricity because they allow electrons to flow easily inside them from atom to atom. Also, conductors allow the transmission of heat or light from one source to another. Properties of conductors. They should have a low specific resistance. They should be mechanical rigid. They should be easily available and should not be much costly. If the conductor is metal, then it should be ductile. Examples of conductors: copper, brass, steel, gold, aluminum. Uses of conductors: copper, electric wires, winding wire, transformer. Brass, electrical accessories. How conductors works. So let us take battery, lamp, nail, and wire. Positive terminal of the battery is connected to one end of the lamp and negative terminal of the battery is connected to one end of the nail. Now the circuit said to be open. Now the another end of the lamp and another end of nail is connected, thus the lamp glows and it is said to be closed circuit. Now lamp glows, because the flow of the electrons from negative terminal of the battery to the positive. Here the nail acts like a switch. We need to understand that wire is made up of copper, and the nail is iron. Thus the both are conductor in nature, and they conduct electricity because they allow electrons to flow easily. Insulator. Insulators are the materials or substances which resist or don't allow the current to flow through them. In general, they are solid in nature. Insulators don't have any free electrons. It is the main reason why they don't conduct electricity. Properties of insulators. An insulator should have a permanent nature and its property should not finished by a change in physical conditions. An insulator should have a value of breakdown voltage. An insulation it should be capable of their mechanic. Examples of insulators: glass, plastic, rubber. How insulators works. So let us take battery, lamp, rubber, and wire. Positive terminal of the battery is connected to the one end of lamp. The negative terminal of the battery is connected to the one end of the rubber, thus the circuit said to be open circuit. Now the another end of the lamp and another end of the rubber is connected. But lamp doesn't glow. Because rubber is an insulator material which resist or don't allow the current to flow through them, thus they don't have any free electrons, is the main reason why they don't conduct electricity. Semiconductors. Semiconductors are materials which have a conductivity between conductors, generally metals, and non-conductors or insulators, such as most ceramics. Semiconductors can be pure elements, such as silicon or germanium, or compounds such as gallium arsenide or cadmium selenide. Its resistivity falls as its temperature rises. Properties of semiconductor. Variable electrical conductivity. Excited electrons. Light emission. High thermal conductivity. Thermal energy conversion. Examples of semiconductors: gallium arsenide, germanium, silicon. Energy band. In gaseous substances, the arrangement of molecules is not close. In liquids, the molecular arrangement is moderate. But, in solids, the molecules are so closely arranged that the electrons in the atoms of molecules tend to move into the orbitals of neighboring atoms. Hence the electron orbitals overlap when the atoms come together. Due to the intermixing of atoms in solids, instead of single energy levels, there will be bands of energy levels formed. These set of energy levels, which are closely packed are called as energy bands. The energy bands are classified into three types: valence band, conduction band, forbidden energy gap. The figure shown is energy band. Valence band. The electrons move in the atoms in certain energy levels, but the energy of the electrons in the innermost shell is higher than the outermost shell electrons. The electrons that are present in the outermost shell are called as valence electrons. These valence electrons, containing a series of energy levels, form an energy band which is called as valence band. The valence band is the band having the highest occupied energy. Conduction band. These are called as free electrons as they tend to move towards the neighboring atoms. These free electrons are the ones which conduct the current in a conductor and hence called as conduction electrons. These are called as free electrons as they tend to move towards the neighboring atoms. These free electrons are the ones which conduct the current in a conductor and hence called as conduction electrons. The band which contains conduction electrons is called as conduction band. The conduction band is the band having the lowest occupied energy. Forbidden gap band. The gap between valence band and conduction band is called as forbidden energy gap. As the name implies, this band is the forbidden one without energy. Hence no electron stays in this band. The valence electrons, while going to the conduction band, pass through this. The forbidden energy gap, if greater, means that the valence band electrons are tightly bound to the nucleus. Now, in order to push the electrons out of the valence band, some external energy is required, which would be equal to the forbidden energy gap. Depending upon the size of the forbidden gap, the insulators, the semiconductors and the conductors are formed. Insulators are such materials in which the conduction cannot take place, due to the large forbidden gap. Examples: wood, rubber. The structure of energy bands in insulators is as shown in the following figure. The following are the characteristics of insulators. The forbidden energy gap is very large. Valence band electrons are bound tightly to atoms. The value of forbidden energy gap for an insulator will be of 10 electron volts. For some insulators, as the temperature increases, they might show some conduction. The resistivity of an insulator will be in the order of 107 ohm-meter. Conductors are such materials in which the forbidden energy gap disappears as the valence band and conduction band become very close, that they overlap. Examples: copper, aluminum. The following figure shows the structure of energy bands in conductors. The following are the characteristics of conductors. There exists no forbidden gap in a conductor. The valence band and the conduction band gets overlapped. The free electrons available for conduction are plenty. A slight increase in voltage increases the conduction. There is no concept of hole formation, as a continuous flow of electrons contribute the current. Semiconductors are such materials in which the forbidden energy gap is small and the conduction takes place if some external energy is applied. Examples: silicon, germanium. The following figure shows the structure of energy bands in semiconductors. The following are the characteristics of semiconductors. The forbidden energy gap is very small. The forbidden gap for Ge is 0.7 electron volts, whereas for C is 1.1 electron volts. A semiconductor actually is neither an insulator, nor a good conductor. As the temperature increases, the conductivity of a semiconductor increases. The conductivity of a semiconductor will be in the order of 102 ohm-meter. Differences between conductors, semiconductors, and insulators. Basis of comparison. Description. Conductor is a material which permits the electric current or heat to pass through it. Semiconductor is a material or substance that may act as a conductor as well as insulators under different conditions. Insulators are materials or substances which do not allow heat or electricity to pass through it. Conductivity. Have very high conductivity, 10 to 7 m, thus they can conduct electrical current easily. Have intermediate conductivity, between 10 to 7 m to 10 to 13 m, thus they can act as insulator and conductor at different conditions. They have very low conductivity, 10 to 13 m, thus they do not allow current flow. Charge carrier. In conductors, electrons are charge carriers. In semiconductors, intrinsic charge carriers are holes and electrons. Insulators do not have any charge carriers. Valence electrons. They have only one valence electron in the outermost shell. They have 4 valence electrons in the outermost shell. They have 8 valence electrons in the outermost shell. Band gap. In conductors, there is low energy gap between the conduction and valence band of a conductor. It does not need extra energy for the conduction state. The band gap of semiconductor is greater than that of conductor but smaller than that of an insulator. The band gap in insulators is huge, which needs an enormous amount of energy supply to push electrons into the conduction on Instagram band. For updates. Thank you. Examples: gold, copper, silver, aluminum, etc. Silicon, germanium, selenium, antimony, boron, etc. Rubber, glass, wood, mica, plastic, paper, etc. Application: the metals like iron, copper, aluminum, etc. that conduct electricity are made into wires and capable for carrying electric current. Semiconductors are used everyday electronic devices such as cell phone, computer, solar panel, etc. as switches, energy converters, amplifiers, etc. The insulators are used for protection against high voltages and prevention of electrical short between cables in circuits. Thanks for watching. Do like, share and subscribe our channel and also follow us on Instagram for updates. Thank you.